Good morning, ladies and gentlemen. Today we're looking at our favourite body from Year 8, Pythagoras. Good to get notes down, and good to have this process in place so it's just reflex for you so you don't mess it up, because you can get these wrong, which is a really frustrating way to lose marks in a test. Alright, you've all met Pythagoras before. It is a squared plus b squared equals c squared, where we're using a right angle triangle. C is the hypotenuse, A and B are the other sides. It doesn't matter which way around we get them. So let's say we're trying to find the unknown side here, x. We, first of all, and this importantly, label the sides. The x is the hypotenuse, the others are a and b. It doesn't matter which way around we get them. Right? Then we substitute into the formula. So I would write the formula first, a squared plus b squared. Then sub in the numbers. 123 squared plus 160 squared is equal to x squared. Now, note from here, you can just reach for your CAS calculator. You can reach for your CAS will give you two answers. One will be positive, one will be negative. Ignore the negative one, the other one's your answer. Otherwise, you can do it by hand, which, well, basically ends up as square root of 123 squared plus a CAS anyway. So I will... And that gives us an answer of 201.81 meters rather. Right. Now, that's how you solve it if the hypotenuse is unknown. If the hypotenuse setup is exactly the same. You start with a squared plus b squared equals c squared. Label the sides, a, b, c being the hypotenuse because it's opposite the right angle. Then sub in the values. A is 12, so 12 squared, plus b is x squared equals 13 squared. Now, honestly, reach for your CAS, it gives you x. However, because sometimes in multiple choice, they might show you the next line of working and ask you to find which the correct line of working will be. Your next line of working would be x squared is equal to 13 squared take 12 squared. X squared is equal to 169 minus 144, 5. X is equal to 5. Now note, x is a whole number, centimeters. When we have three whole numbers with Pythagoras, we can call that a Pythagoras triple. 5, 12, 13 is one example of Pythagoras triple. They're also called as triads, and here are some others. So these are the hypotenuse sides. We just discovered, if you like, 5, 12, 13. There's also 3, 4, 5, and a whole bunch of others. Note that if we take any one of them and multiply it by a number, say 2, 6, 8, 10 is also a Pythag triple. Or multiply it by 3, 9, 12, 15 is a Pythag triple as well. So it's worth having them down. Triples, triads do come up quite a lot, and you will start recognizing them if we do enough questions. And note, there are infinite different ones. We don't just get infinite different ones from multiplying them by different numbers. There are infinite distinct Pythag triples, which is kind of cool. Alright, now, using this in 3 dimensions isn't too bad because we just want to convert it to 2 dimensions. The edge of a cube is 15 centimeters. Find the distance between the centers of 2 adjacent faces. Now note that in a question, they might just give you that. They might not even give you a drawing. If they do give you a drawing, note that it is not always the scale. Clearly, the thing you're looking at is not a cube. I just didn't find a cube on the internet for you. Sorry, you'll have to deal with a rectangular prism. Pretend it's a cube. Now, when they adjacent faces, adjacent means next to, centers of 2 adjacent faces means essentially we're trying to find the distance between the bottom of the floor and the bottom of another adjacent face. Sorry, the middle of another adjacent face, meaning possibly on the side here. It's not to scale, but that's fine. We want to find this length here. Now, because we are on the center of the adjacent faces, I know that this length here is 7.5. And at this stage, when you start drawing a few things in here, I would encourage you, almost tell you, to take the diagram out of the 3 dimensions. As soon as you feel like you've got a triangle with a right angle, or even a non-right angle, because you can do non-right angle trig, take it out, work in 2 dimensions. So working in 2 dimensions over here, we would have a side, 7.5, 7.5, unknown. That's the length we're trying to find. Note we're still working in centimeters here. Then, label the sides, A, B, and C. A, B, C, C being the hypotenuse, opposite the right angle. A squared plus B squared equals C squared. I'm getting slack with my 2's. Sub in 7 point if you would like. Or we come out with x equals 10.61 centimeters. Seems reasonable, so we'll move on. Alright. Find the distance from the midpoint of SR to the point T. So we're aiming for here, the midpoint of SR to the point T. And we can rule a line in there, looking like this. Alright, now, trick with right-angled trig, or right-angled Pythagoras in 3 dimensions, is trying to find right-angled triangles. Here, I would be trying to make a right-angled triangle by dropping a line down here and putting another along the base. And then we try and figure out what measurements we have. Well, one measurement is 10. That's easy, because we know that this one's 10 and this 10, so the base must be 10 as well. But it would be really useful to find the height. So keep in mind, eventually we want to go for this diagonal, which I'm going to call x. But first, I might go for this h height. And in order to go for the height, I might have to use a different triangle. This different triangle will look like this. When you've got a triangle, take it out. Work it off to one side. We know that this is 2 because it's half the base. Hypotenuse is 4. This is the height. And C squared is equal to A squared plus B squared. 16 take 4 is equal to H squared. H is equal to root 12. Now, if you're doing intermediate steps, you could simplify root 12 to a decimal. But for now, I'd leave it as root 12, and you'll see why in a second. So bear in mind, up here, h is root 12. Alright? Now let's take out the other triangle. The other triangle is this one here. The reason we're taking it out is because now we know 2 of the sides. When we know 2 of the sides, we can take it out. (10) root right angle. A, B, C. A squared plus B squared equals C squared. So 10 squared plus squared. Right. Here's why we were after putting it in brackets. I really hope that didn't freeze. No, we're still good. Alright, 100 plus root 12 squared. The square root of 12 squared, the root and the 12 cancel each other out, so we're left with 12. Now, if you left that as a decimal, you'd be getting something very close to 12 there, but it would have been a rounding error. So try and keep the intermediate steps as square roots. If you want to be really fancy, you can write that as 2 root 3, but you don't need to. Root 12 works out quite well, equal to the square root of 112 centimeters. Now, this is an interesting point. Do you leave it as a square root? What happens if they ask it to 1 decimal place? This, as we've all done a lot of maths before, is the absolute mathematical correct answer. However, because in further, rounding and writing to significant figures is something that can be awarded marks, you can also lose marks for not rounding, which seems like an incredibly frustrating thing to do. So if you're asked this to 2 significant figures, you need to write the decimal approximation of root 112, which is root 112. Yes, I know it's 4 root 7. Give me the decimal. 10.583. So that is equal to 10.583 centimeters. Or if you're asked for 2 significant figures, you would write it as 11 centimeters. So note, if you were just asked to find the length, we would accept that or that or that. if you were asked to find the length of two significant figures, they would both be wrong. The 11 would be correct. It's brutal, but there it is. Alright, thank you very much for watching. We'll do plenty of practice in class because everybody loves a bit of Pythag.